geobyte.
Let us take the another important problem. Look at this problem. Asking like this. The heart of a man pumps 5 liters of blood through the arteries per minute at a pressure of 150 mm of mercury. It is given that volume flow rate, volume flow rate, volume flow rate of blood, volume flow rate of blood. Let me write it clearly. Volume flow rate of blood, that is Q or dV by dt, dV by dt is equal to 5 liters per minute. Let us convert it into meter cube per second. 5 into 10 power minus 3, it is in meter cube. For getting in seconds, dividing by 60, it is in meter cube per second, that I can write as dV by dt. That is volume flow rate. And you know that pressure of the rate pressure in terms of mercury, mercury column, that I can rate as H, right, in terms of mercury given 150 mm of Hg, it is equal to 150, it is 0.15 meters of Hg. Okay, if the density of the mercury is 13.6, density of the mercury is given 13.6 into 10 power 3 kg per meter cube, and acceleration due to gravity, gravity constant is given 10 meter per second square. Then power of the heart in watt. What is the power of the heart in watts or joule per second? So power of heart P equal to pressure multiplied by volume flow rate, volume flow rate. So pressure equal to what? Rho of the mercury into G into H of the mercury into dV by dt. Here rho of the mercury. Look at the rho of the mercury. 13.6 into 10 power 3. 13.6 into 10 power 3. G10. Height of the mercury given 0.15 meters. dV by dt. Look at the dV by dt. 5 into 10 power minus 3 by 60. 5 into 10 power minus 3 by 60. Now let us cancel this 10 power 3, 10 power minus 3. Then it is 13.6 into 10 into 0.15, 1.5 into 5 divided by 60. Divided by 60. So here it is. It can be written as okay, 5 12 times. 12 times. It is 13.6 into 1.5 divided by 12. You simplify this value for getting approximately 1.7 joule per second or watt. That is the power of the heart. 1.7. Look at the options. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Then let us take the another important problem asking like this. The cylindrical tube of a spray pump has a radius capital R, one end of which has n fine holes, each of radius cap small r. If the speed of the liquid in the tube is capital V, the speed of the ejection of the liquid through the number of holes. It is given that a cylindrical tube is there, a cylindrical tube is there. That cylindrical tube is maintaining the radius r, one end of which has n fine holes of each radius r. The speed of the liquid in the tube is capital V. Then volume, right? Volume inflow rate is equal to area multiplied by velocity. Area multiplied by velocity. Area pi into capital R square into velocity given V. Okay. Then volume outflow rate. Volume outflow rate. The volume outflow rate equal to radius of the each hole is R. Pi R square is the each area. Let us assume velocity U, right, into number of holes N. But remember, volume inflow rate must be equal to volume outflow rate. Let me write that point. But but volume inflow rate must be equal to volume outflow rate. Outflow rate. Volume inflow rate is pi R square into V equal to outflow rate N into pi small r square into U. You are asked to decide what is the value of U. Here, pi will be cancelled. Pi will be cancelled. Then it is r square into V equal to N r square into U. From this, the velocity or speed of the ejected liquid particles through the fine holes. V r square by N r square. V r square by N r square. Look at the options. No option is available. This may be the printing mistake. V r square by N r square. Right? With this correction, I can select the A. Anyhow, answer is the speed of the liquid particles, ejected liquid particles through the each fine hole is V r square by small n small r square. Option A, I am correcting with V r square by N r square. Option A is correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A fluid is in streamline flow across a horizontal pipe of variable area of cross section. For this, which of the following statements is correct? Look at the option A. The velocity is maximum at the narrowed part of the pipe and pressure is maximum at the widest part of the pipe. Absolutely correct. Okay. For that, look at the pipe which is connected horizontally with variable cross section. For this pipe, I can say this is the widest part of the pipe, that is marked as 2, and 1 is the narrow part of the pipe. Okay, narrow part of the pipe. Okay, now at section 1, let area be the A1, velocity be the V1. Similarly, at section 2, area be the A2 and velocity be the V2. Okay. Then if I take the continued equation, that is A1 V1 is equal to A2 V2. From this, V1 equal to A2 V2 by A1. Look at the area at state 1. Area at state 1, A1 less than A2. Because of the small area, velocity is maximum. From that, I can conclude that in the narrowest part, velocity is maximum. Okay. Similarly, let us connect the Bernal equation between the part 1 and part 2. That is narrow part and widest part. That is P1 plus half rho V1 square equal to P2 plus half rho V2 square. Okay. From this, P2 equal to P1 plus half rho V1 square minus half rho V2 square. As you know, V2 equal to A1 A1 V1 by A2. Since A2 is more than A1, bigger the area, velocity will be maximum. When the velocity is low, let us change the color of the marker. When the velocity of the low, this part is becoming low. When this part is low, pressure is maximum at the widest part. That's why I have selected option A. Understood clearly? Yes, concept oriented question. Okay. Similarly, let us take the another important problem. It is asking like this. The wettability of a surface of a liquid depends primarily on, dear friends, remember whether the solid surface by the liquid is becoming wet or not, completely depending on the angle of contact. Remember, when angle of contact theta equal to 90 degrees, no wettability, no wettability. Okay. Wettability of the solid surface is possible only when theta is less than 90 degrees but more than or equal to 0 degrees. Therefore, angle of contact between the surface and liquid deciding the whether the solid surface is becoming wet or not. Understood clearly? Yes. Similarly, look at the another important problem asking like this. A tube of length L is filled completely with an incompressible liquid of mass m and closed at both ends. The tube is then rotated in horizontal plane about one of its ends with uniform angular velocity omega. This is the angular velocity omega. The force exerted by the liquid at the other end. Force exerted equal to centripetal force only. Centripetal force. The centripetal force Fc equal to m r omega square, but r equal to L by 2, r equal to L by 2. It is m L by 2 into omega square. It is m L omega square by 2. That is the centripetal force acting at the other end of the tube. ml omega square by 2. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Then let us take the another important problem asking like this. A rectangular block of mass m and area of cross section A floats in a liquid of density rho. If it is given a small vertical displacement from equilibrium, it undergoes with a time period t. Then time period. As you know, time period time period t equal to 2 pi into root over m by rho into a into g. That is the time period. From this here, mass remains same, rho remains same, g remains same. I can say time period is proportional to 1 by root to a. This is the relation between the time period and cross-sectional area. So time period t is proportional to 1 by root a. Option C is absolutely correct. Understood clearly? Yes. Similarly, let's take, oh, completed. All the problems what we prepared completed. I hope all of you clear understood. Understood or not? Yes. Thank you. Thank you very much. Okay.
Geobyte.